Hello, it's Mrs. Carpel. We're back taking another look at examples from section 5.4, solving special systems of linear equations. The focus today is going to be on our word problems or application problems. So let's take a look at our first example. A factory has machines that produce toys, which are then packed by the factory's workers. One day, each machine produced 14 toys, and each worker packed 2 toys, so that a total of 40 toys remained unpacked. Additionally, the number of workers that day was 8 less than 7 times the number of machines. How many machines and workers were there? So let's identify some variables first and begin solving this. So let's let x equal the number of machines and let y equal the number of workers. So from the first sentence we know each machine produced 14 toys, each worker packed 2 toys, and there were a total of 40 toys that remained unpacked. So we have 14 toys per machine, so that's going to be 14x, and we have 2 toys per worker. I'm not going to put a plus just yet. We're going to talk about that in a minute. 14x, 2 toys per worker, for a total of 40 left over. Now, if we have toys left over and we have workers that are packing and toys that are being made, we're not going to want a plus sign between our 14x. We're going to want a minus sign because they're packing the toys that are being made, and the 40 represents the toys that didn't get packed. So of the total toys, if we subtract the toys that were packed, that's represented by the 2y, that will equal the number of toys that were not packed. Then we can look at the number of workers that day. So the number of workers was 8 less than 7 times the number of machines. So workers is y. Was is like is, so equals 8 less than, so we're taking 8 away from 7 times the number of machines, so that's 7x. Now it looks to me like we have a system that's set up nicely for substitution because that second equation is y equals. So I'm going to take this 7x minus 8 and I'm going to put it in for y in our first equation. So that's 14x minus 2 times 7x minus 8 equals 40. So to solve this, we need to distribute, and we're going to distribute a negative 2, not just a 2, so we can keep the signs as they should be. So 14x, negative 2 times 7x is negative 14x. Negative 2 times negative 8 is a positive 16 equals 40. And then we can simplify 14x minus 14x. That eliminates, and we are left with 16 equals 40. But that's not true. So if that's not true, and we don't have any variables left, we don't have a solution. There is no solution. This problem can't realistically happen. We can't figure out how many machines and workers there were because this is a scenario that wouldn't work. Let's take a look at our second example. The perimeter, keep in mind perimeter is distance around. of the trapezoidal piece of land is 72 kilometers. The perimeter of the rectangular piece of land is 216 kilometers. Write and solve a system of linear equations to find the values of x and y. Well, if perimeter is distance around, I can write for the trapezoid 2x plus 6y plus 4x plus 6y equals 72. And for the rectangular piece of land, I can write 18y plus 9x plus 18y plus 9x equals 216 kilometers. And now let's simplify each of these equations. So if I combine like terms, 2x plus 4x is 6x, 6y plus 6y is 12y equals 72. Oh, I forgot my y on that 18 there. And then we have, I'm going to start with the x's so that we have our x's lined up in our system. 9x plus 9x is 18x plus 18y plus 18y is 36y equals 216. So now we have a system and everything is lined up, so I'm going to go ahead and use elimination, and I know that 6 goes into 18 3 times, and to make it the opposite I'm going to multiply by negative 3. So I'm going to take everything in that first equation by negative 3. So now my system will be negative 18x minus 36y equals negative 216. Second equation is still 18x plus 36y equals positive 216. Add my two equations together, and the 18x's are opposites, the 36y's are opposites, so I have 0 equals negative 216 plus 216 is also 0. That is a true statement, but we don't have any variables left. In that case, we have infinitely many solutions. There is no one right answer to this problem.